So welcome to the second part of this tutorial. In part one, we showed how to create this moment frame, this frame structure. And one thing that we explained was that there are areas of this model where we want node duplication. So this short element here to the left is not directly connected to this long horizontal element to the right. Each of them has its own nodes. They're not connected into one single node because these are the areas where we will introduce our zero length link elements, our moment hinges. So we want a zero length link element connecting the rightmost node of this member and the leftmost node of this other member. So they are disconnected here. We will connect them through a link element. There are other areas where we have one single node connecting this horizontal member, for instance, and this vertical one means that these two elements are directly connected at one single node. But again, the areas where we will have link elements, we have node duplication. They're not connected directly. And the same goes for any other areas. So we could query what we have in here. We only have node 5. Here, however, we have node 14 and node 8. So what we're going to do next is to define our link elements, our moment hinges, and apply them to the model. So we're going to do that through meshing element groups. We're going to add a new element group, a new link element group. This is going to be a first floor moment hinge. This is going to be a moment hinge element subtype. This is the first thing that we need to specify. And we're going to make sure that we have all results selected. We are going to specify the material for this moment hinge link element. And we can do that in two ways, through link property sets or through material property sets. If we choose a material property set, then this is a way of introducing the material for the link elements in the more traditional way by inputting a stress strain curve. But here we want to add a moment rotation, or to use a moment rotation curve to describe the behavior of these link elements. So we're going to use a link property set. We click on the three dots and we add a new property set. We don't have to worry about the translational degrees of freedom of the link elements. They will be by default constrained. So we can't physically separate, or we won't be able to physically separate the two nodes of one link element. We only have to worry about the rotations. And because we are working in 2D, we only need one rotation. So we click on any of these three dots. It doesn't matter which one. We're going to define a plastic multilinear link element property. We're going to add the first floor property, and we're going to define a elastic stiffness of 8.48 E7. It's a moment rotation curve, and we're going to introduce our values. These are the same as on primer problem 72. 21377. And 0.48140. We click on save. We see that this rotation has been changed slightly. This row is the elastic portion of this curve. So it has to be consistent with the stiffness that we've introduced in here. If not, the rotation will be adjusted so that moment divided by rotation equals the linear stiffness. And we can graph, this is our moment rotation curve for this particular property. And we're going to take the opportunity that we are in here to define also the second floor property. This is going to be a 1.925 E7, and we're going to clear and retype some values in here. 0.020 568 11492 and 0.99 119 657 and 0.4 4375. We click on save, and again, rotation has been adjusted, and the graph is, well, we could plot it as well. So we have two properties, both plastic multilinear. Our first property set will have a property number 1, and property set 2 will have property number 2 in here. So the element group 3, which is for the first floor, will have property set 1, save, and we can copy this into element group 4. This will be our second floor moment hinge, and we'll have property 2. So the next task is to actually apply these link elements in the model. So we're going to do that through meshing, elements, element nodes. Let's start with element group 3, which is the first floor. So let's have a look at what we got in here. So we're going to query these two nodes, which are 13 and 7. So the label, this link element label, doesn't matter. We can call it whatever we want. The important thing is that we put the right node 1, node 2. So we have a 0 length link element right in between coincident nodes 13 and 7. And this is what is connecting both together. And we go to the other side, and we query again. And here we have 14 and 8. 14 and 8. And then we go to the top floor. And let's see what we have in here. 11 and 9. And here we have 12 and 10. So if we switch off the nodes labels and we switch on the element labels, we see that here we have 12, 10. Here we have 11, 9, and so on, right? So there is one last step. We need to control the orientation of those link elements. So here, if we go back to our properties, we see that we have assigned the rotation stiffness, those moment rotation curves, to the local t or around the local t direction of the link element. So we will want to have the local r as aligned with the global x-axis and the local s aligned with the global y-axis, so that t aligns with the global z. So we're going to do this through meshing, elements, element data. Let's start with element group 3, just to go in order. So we control the local r of the link element with the x, y, and z vector, and we want it parallel to the global x axis. And we want the s to be parallel to the global y, which we control with x0, y0, z0. So we're going to have 1 and 1 in here. And we're going to do the same with group 4. We want 1 and 1 in here, and 1 and 1 in here. Right, so that concludes the preparation of this model. We could just move on and solve it. So we're going to do that through solution, data file, and run. And we can call this untitled and let it run. It will have to do 50 time steps at 0.2 increments. So we've solved the analysis. This concludes part 2. Now on part 3, we will see how we interrogate results and how we obtain a few graphs from this model. Thank you very much for watching.